In this video I will talk about the Raspberry Pi. It's a crazy idea of a video game developer named David Brabham. He wanted to build a small computer for less than £50 since he's British. His primary objective to make it accessible to all, particularly for the teaching of computing, automation, and robotics in schools around the world. A tool for students who cannot afford to buy a computer, as well as those who cannot afford to buy a computer but can get their hands on old hardware like screens and keyboards. Keeping in mind that what needed to be new and high quality was the heart of the machine, the motherboard and the processor. I'll show you what a Raspberry Pi is, and what it can do, what it looks like and how it is used. When I tell you a Raspberry Pi is a computer reduced to the minimum, I do mean the minimum because it's just the contents of this small box. When you open it, what you find inside is just a board on which we will find most of the intern components you were presented in the sequence where we showed you what was inside a computer. So, this is the processor, the RAM, and here we have the various communication ports. HDMI port, which enables to connect to any television or computer screen. RCA video port, also for televisions but for older generations TV model. Here is the audio port on which you can plug your headset. The same one you use on your phone and exactly the same kind of audio jack. Here 2 USB ports. The Ethernet port, for the network connection if needed. To get it running we are missing a few things to have a proper computer. So I mean a screen, a keyboard, but also power supply, a bit of memory which will be provided by an external hard drive. And that's what needed to connect all this. I'm going to go and get everything that's missing to build a computer out of this. I did my shopping and I have gathered the missing components. I got a USB keyboard. And a USB mouse going along with it. I got a screen in HDMI format, which is the format of the Raspberry port. I have a Wi-Fi key that will allow me to connect the Raspberry to the Wi-Fi network. However, if I had a newer Raspberry version, I would not need that key because Wi-Fi is directly built in the latest models. Because I need memory space, so I retrieved this micro SD card and SD adapter, which will fit into the connector at the back of the Raspberry Pi. Before inserting this card into the Raspberry, there was a small task that needs to get done. I mean that in order to get the Raspberry running, we need an operating system. The recommended operating system for this machine is Linux, a Debian version. You have to go and get this operating system and install it directly, already on the memory, so that we can use the Raspberry. There are micro SDs with the operating system directly pre-installed if you don't know how to do it. And the steps are well documented and available on the Raspberry website. I'm going to plug in the various USB devices, and at that point, I realized that I have 3 USB devices but only 2 USB ports, so if I had a newer Raspberry version I would have 4 USB ports, but since that's not the case I'm going to use a USB multi-plug because it can lack the power to charge the USB devices. Which has another advantage: the plugs are electrically powered well to have a keyboard running. That's not very important, but regarding the Wi-Fi key and the mouse, that saves power for the Raspberry. I plugged the keyboard, the mouse and the Wi-Fi key without forgetting anything. Here I have the screen, but it is not connected. You have to plug it into the HDMI port. Now that everything is plugged into the USB hub, we need to connect it to the USB port of the Raspberry. All I need now is the power supply. Here is a Smile 5 volts external power supply. That will trigger the Raspberry startup automatically. There you are, it should start now. So with this Raspberry Pi, we managed to start. We find ourselves in a classical Linux working environment. We have access to a wide range of tools we always find in other computers. For example, we have an internet navigator, we have a text editor, we have classic code editing tools. We should also mention the 2 languages are included in this package. One development environment is the Python language, the other is the Wolfram language, is better known as Mathematica, that enables to do a wide range of calculations and graphical manipulations amongst others. But what's more that we don't find in a classical computer but that we do find in the Raspberry Pi is that we have access to something I have not shown you until now, so I will show it to you now. I'm talking about that part, the connectors. These connectors are called POS for general ports for input and output. Those are small logical connectors which you can read or write signals through languages, particularly Mathematica and Python. We'll be able to read and write on these connectors, as well as connect them to objects such as electronic cards, to sensors, and to be able to use the data we collect to activate other objects based on the calculations we've made. To illustrate how we can use these PO connectors, we have retrieved a small robotic arm, which is a toy that we sacrificed for this occasion. We transformed its remote controller into a small electronic patch-up so that the orders will be given simply by sending signals right, left, up, down with 4 of the wires that are plugged into these connectors. The others aren't plugged. They're a Go demonstration, so we have some code here that's Wolfram language, a bit of code that sets up the orders we send to these connectors, and I gathered all this into some small button so demonstration. So up, down, to the right at the same time. We stop it going back to the left. The batteries that make it go left are a bit more tired, but we can still go to the left and up at the same time. So here's what we can do with the output-input control ports of the Raspberry Pi.